Okay, so this video we are going to discuss May-June 2022, paper 1-2. Okay, so question number 1. It is given that the coefficient of x power 4 in this expansion is equal to the coefficient of x squared in another expansion here, and they want us to find the positive constant a. Alright, so to expand any term in the binomial expansion, basically the general formula will be NCR, where I'm having a power n minus r and also b power r. Right? So let us have a look for the first expansion here. I'm having 3 plus x. I'm having 3 plus x power 5. To get the x power 4, in our answer, I will have 5c something and then 3 power 5 minus something and also x power something. To get the x power 4, right, I think it is quite obvious that the power for the x must be a 4. The power for the 3 must be a 1, so that 1 plus 4 equals to 5. And for this value here, you can have 5c4. You can follow the number, the power at the back or the power in front also can. Okay, so when I try to expand this particular term by using calculator, 5c4 times 3, I'm having 15. Therefore, the coefficient for x power 4 is actually 15. And now for the second expansion, I'm having 2x plus a over x power 6. Okay, so for this particular expansion, to get the term with x squared, we might need to analyze a little bit, where I'm having 6c something, 2x power something, and then a over x power something. Alright, so definitely the power in front must be bigger than the power at the back, so that eventually I can get the power of x squared. Alright, so when we try to analyze for the power that add up can be equals to the 6, right? We realize that 4 and 2, where 4 plus 2 equals to 6, and for the term in front I'm having x power 4 divided by x power 2, therefore my final result will be x power 2. Therefore, this will be the correct power. And when I fill in the value for the combination, it will be 6c2 or 6c4, also no problem. Okay, so from here, if I try to press out all the value from the calculator and simplify it, I'll get 240 a squared and then x power 2. Okay, so for this question, they are talking about the coefficient. So coefficient of x power 4 is equal to the coefficient of x power 2, which means that coefficient is the number in front of this particular term. So 15 should be equals to 240 a squared. So I will let 15 equals to 240 a squared. And of course, I try to simplify and get the value where I should have plus minus square root 1 over 16. Because of the question already mentioned that they want us to find the positive constant a, therefore the final answer that we accept for a will be 1 over 4. Right, so this is how we actually answer question number 1. Okay, so we come to question number 2. We are having the second and also the third term of a geometric progression, 10 and 8 respectively, and they want us to find the sum to infinity. Okay, so basically the formula that involved in this question will be the formula for geometric progression. Okay, so for the n term for geometric progression will be Tn equals to AR power n minus 1. So this is the number of n term, okay, the equation of n term for the geometric progression. And the sum to infinity will be S infinity A over 1 minus R. By using the first two information given in the question, they are mentioning that second and also the third term are equals to 10 and 8. Therefore, when I want to write out the T2, the formula for T2 will be actually equals to A is the value that I don't know, R is also the value that I don't know. I'm having 2 minus 1, which is a 1, and it should be equals to 10. And from here, I actually get the first equation where AR equals to 10. And this is our first equation. Of course, I cannot calculate the sum to infinity yet. I have to find out the A and R before I can calculate the sum to infinity. Then for the second information, they are mentioning that third terms of the geometric progression is 8. So the formula for third term will be, I will substitute n equals to 3. Therefore, I'm having AR power 2 equals to 8. And this will be my second term, second equation. Right? So to solve for the value, to get the value for A and R, basically I need to solve the equation simultaneously. I can take equation 2 divided by 1. So when I take equation number 2 divided by equation number 1, for the left hand side here, I'm having R. I'm having AR squared divided by AR, right? So eventually I'm having the R, which is equals to 8 over 10. And from here, I will get a simplified value for R, which is 4 over 5. Once I get the value for R, I can use the value, substitute it back into the equation number 1 to get the value for A. The first term value should be 25 over 2. If I substitute the value of R into the equation number 1, or also equation number 2, both will give us the same answer for the value for A. Okay, and next step it will be to find out the sum to infinity. Basically, the formula given is A divided by 1 minus R. So A is 25 over 2, R will be 1 minus 4 over 5, and when we simplify, we'll get the number which is 62.5. Okay, so the sum to infinity for this geometric progression will be 62.5. Question number 3. The equation of a curve is such that we are having this equation in dy dx. So dy dx equals to this one. And then it is given that the curve passed through the point 4 and 5 over 2. They want us to find the equation of the curve. So equation of the curve basically is the y. And then from dy dx, to get the y, we have to apply integration. Right? Let's start. To get the y, we have to integrate the dy dx, where it will be the integration of 3, then 4x minus 7 power half, minus 4x power negative half. For the 3 here, it is a constant, therefore I just copy it. For the bracket with x and the power half outside, I will need to add the power by 1. So half plus 1, I'm having 3 over 2. Therefore, for the denominator, I have to divide it by 3 over 2. After that, I have to differentiate the thing inside the bracket. Differentiate 4x minus 7, I get a 4. I also need to divide a 4 in my fraction. So here we complete the integration for the first term. For minus 4, I will just copy it as minus 4. And now I want to integrate this term where I'm having x power negative half. So to integrate x power negative half, power plus 1, I get half. And divide my x half with the half. And here we complete the integration for the second term and we put the constant term at the back. Okay, further simplify all the terms here. I should have half with 4x minus 7 power 3 over 2 and also minus 8 x power half plus c. To get a constant c, I have to apply I have to substitute the value or the information given by the question. So this is the point that is given by the question. And from here, we actually know that 4 is actually the value for the x and 5 over 2 is the value for the y. And I substitute these two values into my equation to get a c. Y is 5 over 2, where 4 times 4 is a 16. Having 4 power half plus c. When I try to simplify everything, all the values here in the equation, and the value for c that I get should be equals to 5. Okay, and to write out, to get the equation of the curve, maybe we should write out the final answer, where the equation of the curve is y equals to half 4x minus 7, 3 over 2, and plus 5. So we'll just put in the value of c that we get just now. Okay, so this is basically the complete equation that we get from the dy dx. Number 4. It is given that the first, second, and third terms of an arithmetic progression are this expression, right? First, second, and the third term. They want us to find the value of the constant k. Okay, so for the arithmetic progression, basically we need to know that the difference between all the terms, all the consecutive term will be the same, right? Which means that if I take 6k minus k, the value should be the same as k plus 6 minus the 6k. So from here I can form one equation where 6k minus k should be equals to k plus 6 minus 6k. Okay, so if I try to simplify both the whole equation here, basically I will get the value of k very easily, where it should be 3 over 5. And for the next part, they want us to find the sum of the first 30 terms of the progression. To find the sum for the first 30 terms in the arithmetic progression, the general formula should be Sn equals to n over 2, 2a plus n minus 1d. Okay, so basically we need to find out all the values here. I need to find out the a, I need to find the value for the common difference, which is the d. If we have a look for the number that we get on top, k will be my first term. So k will be actually 3 over 5. Okay, so k equals to the first term, which is equals to 3 over 5. To get the d, basically we are having 6k minus k, right? You can get it from here, 6k minus k, where I'm having 5k, and substitute the value of k into my calculation here, I'll get my common difference, which is a 3. I already get two important information that I need here. I have a equals to 3 over 5 and also d equals to 3. To calculate the first 30 term, sum of the first 30 term, it should be S30. From here you can see that the value for n is 30. Substitute into the equation, I'm having 30 divided by 2, then 2a plus n minus 1. n minus 1, which is 29, d, so d is a 3. Simplify the value from here. My final answer for the sum of the first 30 terms of the arithmetic progression will be 1, 3, 2, 3. Right, so this is how we actually solve the question number 4. Question number 5. We are given an equation of a curve, and then we have an equation of a line where k and a are constants. So given that the curve and the line intersect at the point where the x-coordinate is 0 and also 3 over 4, they want us to find the values of k and also a. Alright, so for this question, they give us a keyword. To me, the keyword will be the intersection point. Okay, when you want to solve and get the intersection point for curve and also the equation, there are many ways, right? The first one will be, you can try to equate the curve and also the line equation, and then you try to solve for the value of x. So I'm going to use this method. So I will let the curve equation, where I'm having 4x squared minus kx plus half k squared equals to x minus a. Right, so basically when I want to find the intersection point, I'm going to equate these two equations, and after that I solve for the x. Right. Okay, and now since I know that the x-coordinate, one of the x-coordinate is 0, so I substitute x equals to 0 into the equation. When I substitute x equals to 0 into the equation, I will have half k squared, which is equals to negative a. And if I try to rephrase my equation, I'm having negative half k squared for the a. And I will treat this as a first equation. From here, for the second point of intersection, I will substitute x equals to 3 over 4 into the equation again. Right, and from there, I will get 9 over 4. So substitute 3 over 4 into the equation. Alright, I will have 9 over 4 for the first term, and then negative 3 over 4k plus half k squared equals to 3 over 4 minus a. So minus a, I'm having it as minus a. And this is actually my second equation. From here, I would want to substitute first equation into the second equation so that I can solve it again, further solving it to make the a disappear. Alright, so if I substitute first equation into the second equation, basically I'm having negative half k squared. And if I try to simplify this whole equation here, I will have 3 over 4k equals to 6 over 4. And now I get the value for the k, which is equals to 2. Once I get the value for k, which is equals to 2, I will substitute into the equation number 1 to get the value for a. So 2 squared is a 4, divided by 2, you get a 2. Therefore, the value of a will be negative 2. Okay, so we get the final answer where k equals to 2 and also a equals to negative 2. And this is how we solve the part A. Right, then we can proceed to part B now. Okay, for part B, they are saying that now given a is equals to negative 7 over 2, they want us to find the value of k when the line is a tangent to the curve. Okay, so if you recall back, right, we are having a curve equation and also a straight line equation. When they are saying that the line is a tangent to the curve, basically we can find out the intersection and we will use the discriminant concept where b squared minus 4ac equals to 0 due to the reason that we are having the line is a tangent to the curve. And if you try to imagine, right, if let's say we are having a curve, when the line is a tangent to the curve means that the line will only touch the curve at one particular point. Okay, so this is tangent, right? So it will touch the curve at one particular point, and therefore we can try to use the discriminant concept where b squared minus 4ac equals to 0. Okay, so before we start, again, we still need to recall back our equation here. We are having 4x squared minus kx plus half k squared. And then y equals to, it is given now a equals to negative 7 over 2. And our equation becomes x plus 7 over 2. Okay, so I have curve equation, I have the line equation. When I want to find the intersection point, I will let equation number 1 again equate to equation number 2. Okay, now I will group everything, all the terms to one side, and I will arrange them in decreasing power for x. So I'm having 4x squared, then negative k minus 1 x, and the constant term will be half k squared minus 7 over 2, and it is equals to 0. Okay, due to the reason that just now you have the keyword here, right, a tangent to the curve, and we decide to use a b squared minus 4ac equals to 0, substitute the b. A is a 4, and then c will be half k squared minus 7 over 2. And we let it equals to 0 because they only intersect at one point. Okay, so just to recall, this one is actually my value of a, and then the coefficient in front of the x is the b, and the constant term will be the c in the quadratic equation, right? Okay, continue further. Expand this whole equation here. Then try to rephrase everything again and simplify. Eventually, I'll get 7k squared minus 2k minus 57, and it is equals to 0. Okay, from here, we can try to factorize it. I'm having 7k and k. Then I should have 3 with 19 for the 57. And the negative part should be here. This is the positive sign, and it is equals to 0. Okay, then continue further again to solve for the value of k. And here we'll get two values for the k, where k equals to negative 19 over 7, and also k equals to 3. Right? So this is how we actually solve this question number 5. We are now at question number 6. The diagram shows the curve with this equation and also the line with the equation y equals to 2x plus 2. They want us to find the exact area for the shaded region, which is bounded by the line and also the curve. According to this diagram, right, we can see that the area, the shaded area, is actually within the curve and also the line. It is covered by the line and the curve. Okay, so to find the exact area, later our final answer should be in the fraction form, and then try to avoid the long decimal number. Okay, to get the shaded region bounded, the first step is we need to find out what are the intersection points for these two graphs first. I need to find the intersection point. Okay, so that these two intersection points will become the limits of our integration later. It is because of the area also is bounded within these two limits. So we need to find these two values first, and very obvious, you can see these two values actually is the x coordinate for the intersection points for these two curves or these two graphs. Right, so we will start now. The very first step is we try to find out the intersection point where we let equation number 1 equals to equation number 2. So I write it down here. We are having 2x plus 2, and I let it equals to 5x power half. And if I move the 5x power half into the other side, basically I'm having a quadratic form equation. So quadratic form equation means that this equation, although we are having x power 1 and also x power half, but if you want to rephrase it, or you can let y equals to x power half, right? Eventually you will have 2y squared minus 5y plus 2, which is equals to 0. So we call it as a quadratic form equation. For this quadratic form equation, you can solve it by using the normal way like you solve quadratic equation. Okay, so for this particular part here, I'm having the factorization for this quadratic form equation. I will have 2x power half with x power half here. I have 2 and 1. To get negative 5, I have negative 2 and negative 1 here. Okay, so to solve it in further, I'm having x power half equals to 1 over 2, x power half equals to 2, and square the both sides for this equation. I'm having 1 over 4 for the x, and also x equals to 4 for the value of x. So basically I know that I'm having 1 over 4 and also the 4 here. Okay, next step, I will want to find the shaded area. To find out the shaded area, basically the limit start from 1 over 4, the area start from 1 over 4, and the area end at 4. The limit will be 1 over 4 and 4. Okay, and then now I want to take the graph, the higher graph. So the higher graph basically is this one, where it is 5x power half. I will take 5x power half minus the line at the bottom, where it will be 2x plus 2 dx. Okay, basically for this concept is we are trying to find out the area under the 5x power half, then minus the area under the part for 2x plus 2, and then we will get the shaded area. So that's the concept that we are applying now. Okay, so we can further simplify and integrate this. I'm having 5x power 3 over 2 divided by 3 over 2. Negative 2x, if I integrate, I will have negative x squared. Integrate negative 2, I will have negative 2x, and I want to substitute the value for 4 and also 1 over 4. Okay, before I substitute the value or the limit into our calculation here, right, I tend to prefer simplify all my equation first before I substitute in the value. And now I start the substitution. First of all, I substitute 1 over 4. I substitute 4 into my expression here. Substitute 4 for this part, eventually I'll get 80 over 3. Substitute 4 into negative x squared, I'll have negative 16. Substitute 4, I'll get negative 8. And minus, now I want to substitute 1 over 4 into my expression here. Substitute 1 over 4 and simplify it for the first term, I have being 5 over 12. 1 over 4, I'll get 1 over 16 for the square, x squared. And then substitute 1 over 4 into this term, I will have negative 1 over 2. Okay, so just try to simplify everything. I will want to keep my answer in a fraction form where it should be equals to 45 over 16. And basically, this is the area for the shaded region. Okay, so question number 7. We are given a diagram and it shows that we have sector OABC with a circle with a center O and radius 10 cm. The point P lies on OC and BP. Okay, then and it is perpendicular. BP is perpendicular to OC lah. The angle AOC is pi over 6 and the length of the arc AB is 2 cm. They want us to find the angle BOC. Okay, so before you find the angle BOC, basically it consists of two parts for the angle BOC. The first part is this one where we are having the answer which is pi over 6. Another part is this one. So BOC basically means that the small angle plus the pi over 6 to get the answer. Okay, for this small angle here, I will let it as theta. And we are going to use the idea where r theta equals to the length of arc. So I want to have a look for this small sector here. For this particular small sector, okay, r is a 10. Theta is a value that I don't know yet, and s is actually the length of arc, which is the length of arc AB, and it is 2 cm. For our theta here, I will get the value where it should be equals to 1 over 5. And now to proceed and find out the angle BOC, basically it will be equals to 1 over 5 plus pi over 6. And I will leave my answer in this pattern because I expect that in the next part, they might want us to use this angle BOC to calculate the value. So I will keep it as original as possible so that later I can substitute the whole exact angle here into the calculation for the next part. Right, so my angle BOC will be equals to 1 over 5 plus pi over 6. If you want to rewrite it into the 3 significant figure also can, and it will be equals to 0.724. But again, I would prefer to keep it in the exact form so that later when it involves any calculation on this angle, right, I will substitute the exact form into the calculation. Okay, so this is part A. Continue to part number B. For part B, they want us to find the area of the shaded region, BPC, giving your answer correct to 3 significant figures. Let's have a look for the shaded area. To find the shaded area, basically I need to find out the area for the whole sector, OBAC. Then I need to minus the right angle triangle area here. So this is basically what we have for the plan. Okay, so we go back to part B. For part B, when you want to find the shaded area OABC, it is quite straightforward because we already have all the information needed. Alright, so we try to find the area of sector BOC first. The whole area for the sector, it will be half r square theta. Half r square, r is equals to 10, r square, and theta. So theta will be the whole angle that we find out in part 1 just now, which is 1 over 5 plus pi over 6. If I try to simplify this answer, I will get 10 plus 25 pi over 3. And again, I will keep it in the exact form so that I can include this whole exact form into the calculation for the final answer later. Okay, so we have settled with the area of sector BOC. And now we want to figure out how to get the area for the right angle triangle. To get the area for the right angle triangle, I need to know what is the length for the base and also what is the length for the height. From this triangle, if we have a look for this right angle triangle, I can actually write out two equations here. If I try to write out an equation for sine for the angle of 1 over 5 plus pi over 6, that means for this whole angle, right? So what is the formula for sine theta? So for this sine theta, it will be BP, which is the opposite length divided by the hypotenuse, which is the arc, and 10. From here, I will get my BP equals to 10 sine 1 over 5 plus pi over 6. Same thing happens if I try to write out one equation or one ratio, which is about the cos theta, cos angle. So for cos angle, I should have OP divided by 10 also, the adjacent length over the hypotenuse, So I'm having OP also equals to 10 cos 1 over 5 plus pi over 6. Okay, I try to write the answer for BP and also the length for OP in this form so that I can include them in exact form for the calculation of the area of triangle here. So the area for this triangle, basically it is half. Base is OP and then the height is BP. Okay, so we'll go back to our calculation in the second part B. Okay, so for the triangle, I will rewrite again in our calculation. If I have sine 1 over 5 plus pi over 6, I'm having BP, right? So BP over 10. Okay, BP length will be equals to 10 sine 1 over 5 plus pi over 6. Second information or second ratio is cos. So I'm having cos 1 over 5 plus pi over 6. And I get OP over 10 as well. And the length for OP can be written as 10 cos 1 over 5 plus pi over 6. Okay, once I get all this information already, I want to get the area of the right angle triangle for OPB. It will be half times base. So base is OP lah. So I put in the value, the exact value for the length of OP. And also the height. Height is BP. I will put in the exact value for BP to get the area. So by pressing calculator, basically I will get the super long value where it should be equals to 24.8092847.6. Okay, so again, for me, I will keep it as long as possible because this is not my final answer yet. I will continue to the next step to get the shaded area. To get the shaded area in the diagram shown, we need to have the area of sector OBC, BOC minus the area of the triangle OPB. Okay, so I'm having the area sector in exact form, right? 10 plus 25 pi over 3 minus the long value for the area of triangle. Okay, and the correct answer, this is the original long answer, so we can correct it or change it become three significant figure where the final answer should be 11.4. Right, so this is how we get the answer for this shaded area. Okay, so before we end this question, there's one small reminder here. Since we are having the calculation that involve the sine and cos in a certain angle, right? Please take note that this angle is measured in radian, not in degree. Therefore, it will be good if you can put your calculator in radian mode when you apply the calculation in calculator. Okay, so this is how we solve question number 7. Okay, we come to question number 8. It is given that the equation of a circle is like this, and we have point A, point B lies on the circle. They want us to find the value for A and B and hence find the coordinate of the center of the circle. Right, so we try to find out A and B first. My original equation is x squared plus y squared plus ax plus by minus 12 equals to 0. So to get the value for A and B here, basically I need to have 2 points that lies on the circle. Okay, so first I will substitute the point 1, 1, where x equals to 1, y equals to 1 into my equation of the circle. If I substitute into the equation of the circle, I'm having 1 plus 1 plus a plus b minus 12 equals to 0. If I try to rewrite my equation, I will have a equals to 10 minus b. And I assume that this is my first equation. Okay, then now I want to substitute the second point that lies on the circle. So the second point is actually x equals to 2 and y equals to negative 6. If I substitute x equals to 2 and also y equals to negative 6, the value that I get will be 4 plus 36 plus 2a minus 6b minus 12, and it is equals to 0. Then rephrase my equation again. I'll have another equation in terms of a and b, so I will treat this as a second equation. To get the value for a and b, I think it's very obvious. We need to solve these two equations simultaneously, right? So we can start equation number 1 into equation number 2. When you try to substitute it, and we try to simplify, we will have 8b, which is equals to 48. From here, we will get the value for b, which is a 6. And again, substitute it back into equation number 1. So 10 minus 6, you'll get a 4. And the value for a and b comes out. We are having a equals to 4 and then b equals to 6. Okay, so the second part for the question, they actually want us to get the center of this circle. To get the center for this circle, I will try to completing square it for the x and y so that I get the standard form, and from there I get the center. Okay, so I substitute value for b and a into the equation of circle first. ax means 4x, by means 6y, and then minus 12 equals to 0. Okay, this is my equation for the circle. I will start the completing square. I'm having x squared plus 4x. So to complete the square for the x, I have to plus 2 square minus 2 square. Where how I get a 2? It is taken from 4 divided by 2. For the y also the same. I'm having plus y square plus 6y. Then to completing square, I'm having plus 3 square minus 3 square. How I get the 3? I take the 6 divided by 2 minus 12, and it is equals to 0. If I try to simplify these three terms into one big bracket, I will have x plus 2 square minus 4. The negative 2 square means a 4, right? So minus 4. Same thing happen here. I will combine these three terms become a big bracket where I get y plus 3 square minus 9 minus 12, then equals to 0. And further simplify this, I'll get the circle equation looks something like this, where it becomes the standard form of a circle equation. To get the center, we can read the value of the center for the x and y coordinate straight away from the equation, where the center for this circle should be -2 and also -3. Okay, and now we can proceed to the part B. Okay, so for part B, they want us to find the equation of the tangent to the circle at point A, giving your answer in the form of px plus qy equals to k, where p, q, k are integers. Okay, so recall back, what is the point A here? Point A is given in the question. It is actually the point at 1 and 1. Alright, so if we try to imagine, if we have the point A at this part, and they want us to find the equation for the tangent of A with the equation of the tangent at A with the circle. So this is the equation of tangent, right? To form the line, to form this tangent equation, basically we need one passing point, and we already have the passing point, which is 1, 1. We need also the gradient. To get the gradient for this tangent, I will need help for the gradient of center to the A, because the center to A is perpendicular with the line of the tangent. Alright, so I will need to find the gradient of CA first, and then after that I find out the gradient of tangent, and I can form the equation of the tangent. Okay, so we'll start from the gradient of CA. The gradient of CA, you take y1 minus y2 divided by x1 minus x2. I'm having -4 divided by -3. Gradient of CA will be 4/3. Since we know that CA and the tangent are perpendicular to each other, that means if I try to multiply the gradient of tangent with the gradient of CA, right, I will get -1. To get the gradient of tangent, basically I can use this concept. So I will take -1 divided by the gradient of CA. And from here I get -3/4. So this is one important information for us to build or form the equation of tangent. Then the second equation, the second important information will be the passing point. Okay, for the equation of tangent, for any point that is on the line of the tangent. So these two are the important information that I will use it to form the equation of tangent. So now let's start. Equation of tangent. The formula that we are applying is y minus y1 equals to m, then x minus x1. Y minus 1 equals to the gradient, which is -3/4, and then x minus x1, which is a 1 as well. Okay, so further simplify it until we get the equation in this form, px plus qy equals to k. I'm having plus 3 over 4, then plus 1. I'm having 7 over 4. Okay, multiply the whole equation with 4. I will have this. And then rephrase it again. Basically, I'm having 3x plus 4y equals to 7. So this is exactly the form that they want us to show. Alright, so we are having 3x plus 4y equals to 7. We are at question number 9 now. Okay, it is given the equation, we are given the equation where y equals to this one. And then the domain for the equation is x greater than negative 1 over 3. First, they want us to find out dy dx and also d square y dx squared. Okay, so to get the differentiation, basically you just differentiate term by term. Alright, so differentiate 3x, you will get a 3. Differentiate a 1, it is a constant, therefore you get a 0. Copy the negative 4, which is a constant, together with the bracket, right? Okay, so now we integrate, we differentiate the bracket. For differentiation, right, the power you have to put it in front, where I'm having negative 4, multiply with the half, copy the bracket, power minus 1. So half minus 1, you will get negative half. And after that, please differentiate the thing inside the bracket. Differentiate 3x plus 1, we are having a 3. So I have to multiply the term, the expression with a 3. Okay. Then we can further simplify it into an expression where 4 divided by 2 is a 2 times 3, you get a 6. And then 3x plus 1 power negative half. I'll keep my answer in this form for the dy dx so that it will be more convenient for me to continue with d square y dx squared. So now I want to apply and find out the second derivative. To find the second derivative, okay, differentiate 3 is a constant, I will get a 0. Negative 6 attached with the variable x, right? So I will just copy the negative 6. Power negative half, I want to put it in front. So I multiply negative 6 with the negative half. Copy the bracket 3x plus 1. Take the power minus 1. So I'm having negative 3 over 2. After that, differentiate the thing inside the bracket again. So differentiate 3x plus 1, I get a 3. So I multiply with 3. So I try to simplify my answer here to get the most simplified version for the d square y dx squared. Basically, this is what we have for dx y dx squared and also dy dx. Right, we can proceed to the part B. Okay, so for part B, basically they want us to find the coordinates of the stationary point of the curve and also determine its nature. Right, so for stationary point, when you see the word stationary point, basically means that it is either maximum or minimum point. And on the stationary point, the dx dy is actually equals to 0. Okay, so I recall back, what is our dy dx here in part number A? So dy dx basically is equals to 3 minus 6 and then 3x plus 1 power negative half. Okay, and now at the stationary point, I will want to let dy dx equals to 0. Therefore, you can see that I'm letting it equals to 0. And I try to solve this particular equation for the x coordinate. Okay, and I'm having 6 over 3x plus 1 power half equals to 3. Half equals to 2. So I square both sides to make the square root disappear, and I get a 4. So solely simplify it, I will get actually x equals to 1. And they are asking for the coordinates of the stationary point, right? After I get the x coordinate, substitute the x equals to 1 into the y equation. So when I substitute into the y equation, basically I'm having 3 times 1 plus 1 minus 4. Then 3 times 1 is a 3, 3 plus 1 power half. Okay, so to simplify the y, basically I'm having y equals to negative 4. This is the coordinate for the stationary point. And now for the second part, we need to determine whether this stationary point is maximum point or minimum point. To determine whether is it maximum or minimum, I will need to apply the d square y dx square, where I recall back the answer that we get in first part, in part A. D square y dx square is 9 multiplied with 3x plus 1 power negative 3 over 2. And to determine whether the particular point is maximum or minimum, we substitute the x coordinate into this expression. I'm having 4 power negative 3 over 2. Further simplify it, I will have 9 over 8. And this value is greater than 0. When the value of d square y dx square is greater than 0, we can make a conclusion where my point, the stationary point is actually a minimum point. So I will write out the conclusion where this particular stationary point is actually a minimum point. Okay, so this is how we solve question number 9. Okay, so question number 10. We are having the function f and g. We are given the function f and g, and this is what we have. All right. For part number A, they give us a diagram, and then it shows the part of the graph of y equals to fx. So basically, they are sketching the 2x plus 1 divided by 2x minus 1. So this is what we have in the graph here. Okay, so first part, they ask us to state the domain of f inverse. Right, so to find the domain for f inverse, basically we need to use one concept here. And we actually know that the domain of inverse function f should be equals to the range of the function f. Alright, and how to determine the range of the function f? Since the diagram is given for the function f, so we can get the range from this diagram here basically. And you can see that for the range, my function f, the value, right, starts from, the graph continues from the negative infinity until a certain value, and getting closer and closer to this y equals to 1. It is getting closer and closer to the line y equals to 1, but it will not touch the line y equals to 1, where y equals to 1 is actually the asymptote. And for the upper part for this function fx, you can see also the graph will keeps on continue going up, and the value takes will be positive infinity. And to this side of the graph again, you can see that, you can observe that the graph getting closer and closer to the line y equals to 1, but it will not be equals to 1. It will not touch the line. Okay, y equals to 1, where y equals to 1 is asymptote for this function. Okay, so from this diagram, basically we know that the range of the function is, you can write in this way, x can be any value except the 1, right? So you can write x cannot be equals to 1. And this is the range from the diagram. Now, we want to apply the range in this part where the range of function is equals to the domain of the inverse function. When we want to write out the domain of the inverse function, basically we have to change the y. So I make a very big mistake here. These two shouldn't be the x, it should be y, because we are talking about the range, right? Yeah. And then we want to substitute it as the domain of the f inverse. We have to replace the y into the x. Therefore, the domain for the inverse function is exactly the same, just that we need to change the y become x, where x can be any real number except the 1. Okay, basically this is how we decide the domain of the inverse function. Alright, and after that they want us to find out the expression for f inverse x. So usually for f inverse, I will let y equals to the original function where I'm having 2x plus 1 divided by 2x minus 1. Okay, so now I want to rephrase this equation so that it becomes x in terms of y. Okay, so I slowly rephrase it. I'll bring the denominator up. And now I want to try and group all the x to one side, where I should have 2xy minus 2x equals to y plus 1. Factorize out the 2x, I will have y minus 1. Okay, and then keep the x on the left and move everything to the right hand side. Basically, I'm having y plus 1 divided by 2, y minus 1. Okay, so now you can see that my answer is x in terms of y, and which means that this is the inverse function for the f. Okay, so the inverse function f will be x plus 1 divided by 2 and then x minus 1. So I will want to express it in terms of x. And this is how we find out the inverse function f. Okay. Then next one, they want us to get gf inverse 3. Okay, so to find out the composite function gf inverse 3, first of all, we can substitute 3 into the function, the inverse function f. So substitute value 3, x equals to 3 into the inverse function f here. I'm having 3 plus 1, which is a 4 divided by 2. Then 3 minus 1 equals to 2. 2 times 2, 2 times 2 also equals to 4. And we want to find out the value for g1. Okay, g, and substitute the value x equals to 1 into the function g. What is the function g again? You can recall back, function g is actually x squared plus 4. And I should have 1 squared plus 4. And eventually this answer should be equals to 5. Okay, and this is how we answer part C. Okay, next part. For the next part, they are asking for the reason why G inverse cannot be found. Alright, so basically when you want to find any inverse function, you need to ensure that your original function G or the original function is actually one-to-one function. If we have a look at for the equation for this function G and also the domain given, basically if you try to sketch the graph, it will be x squared plus 4 from negative to positive infinity, which means that my graph should look something like this, and this is a value 4 and y equals to x squared plus 4. Okay, so for this domain, basically we take the whole U shape for the diagram that we sketch, and then from this diagram, basically you can see that if I draw any horizontal line, I'll get 2 intersection points, and it means that this is not a one-to-one function. So this is the main reason why the G inverse cannot be formed. Okay, right. So just need to straight away write out the answer. You can tell them that Gx is not an one-to-one function. Alright, and now we go to part E. Okay, so for part E, they want us to show that this expression can be expressed as this fraction. So I think it is quite straightforward. You can start from what they give you here, 1 plus 2, 2x minus 1. If I want to make the whole expression here become one fraction, basically I need to change it become same fraction, right? So same denominator, sorry. So I'm having 2x minus 1 divided by 2x minus 1 plus 2 over 2x minus 1. Okay, then I want to combine these two fractions together become 1. So I'm having 2x minus 1 plus 2. So it is very obvious that I will get the expression that they want us to show. Okay, so we've done the first part. Okay, proceed to the second part. They want us to find the area of the triangle enclosed by the tangent to the curve at the point x equals to 1, x-axis, and also y-axis. Right, so what's the meaning for this question? Basically, if you try to imagine, okay, let's say we are having our function 2x plus 1, 2x minus 1, right? The diagram is given on top. This is what we have here. Okay, and then if we go back, if I try to sketch it by using the graph, so I just simply sketch. Alright, so let's say this is particularly what we have, and then they are saying that the tangent at x equals to 1. So let's say this is x equals to 1, and this is the particular point. The tangent form will be something like this. The tangent to the curve will look something like this. Okay, and you can see that there's a triangle here. Okay, basically they want us to find out the area of this particular triangle that the tangent of the curve form together with the y and also the x-axis. Alright, okay, so we can start doing this. First of all, if you want to know the value, okay, for the x-intercept, which is the base of the triangle, and also the y-intercept, which is the height for the triangle, definitely we need to know the equation of the tangent, as this is tangent, right? Tangent to the curve. Alright, so the very first step here, we want to try and find out the equation of tangent first. I will let y equals to 1 plus 2, and then 2x minus 1 power negative 1. I get this expression from here because I know that the fraction can be expressed in this way, and when I change it become this expression, it will be easier for me to apply differentiation so that I can get the gradient of tangent soon. We can also differentiate this one if we want, but you have to apply the quotient rule. Right, okay, so to avoid the quotient rule, maybe I straight away use this equation, this expression, to get the differentiation. Okay, so I want to get the dy dx. So to get the dy dx, 1 is a constant. Therefore, differentiate 1, you get a 0. 2 is a value that attached with the variable x, you copy the 2. Now for this negative 1, I want to bring it in front, so that I take 2, multiply with negative 1, copy the bracket, and then the power need to minus 1. So negative 1 minus 1, you get negative 2. After that, you need to differentiate the thing inside the bracket. Differentiate 2x minus 1, you get 2. And you can try to simplify this particular term for dy dx. Okay, to get the dy dx, I will have negative 4 by 2x minus 1 power 2. And to get the gradient of tangent at the point x equals to 1, basically you have to substitute x equals to 1 into my dy dx expression. So I'm having 1, and my dy dx is actually negative 4. Right, so please take note that this is basically the gradient of tangent. Okay, I have the gradient of tangent. Alright, I have the x coordinate equals to 1, and to continue, I need to know the y. So when x is equals to 1, to get the y, you substitute into either this expression or this one. Okay, so it will become a 3 I think very obvious. If you substitute x equals to 1 into this expression, you will get y equals to 3. So this is the particular point, okay, that form the tangent with the curve. Okay, so now let us find out the equation of tangent. So to get the equation of tangent, you take y minus y1 equals to gradient of tangent negative 4, x minus x1. So we try to simplify it. And we get this value. Okay. Then now continue further. My aim is to get the x-intercept and also the y-intercept for this particular tangent. So I will let x equals to 0. When I let x equals to 0, I actually get y equals to 7. So that means the y-intercept here is actually a 7. And then if I let y equals to 0, the value of x that I get is 7 over 4. Which means this particular value here is 7 over 4. And now we can proceed to get the area of triangle. Okay, so the area of triangle will be half times base times height, right? So what is the length for the base here? So the length for base is 7 over 4. And then the length or the value for the height is actually 7. And from here, if we try to simplify it, I think we will get 49 over 8. So you can keep it in this fraction form. Alright. Okay, so this is how we solve question number 10. We are at the last question now for this paper, question 11. The function f is given by this one. And the value for x is from 0 until 2 pi, where k is a constant. Given that k equals to 3, they want us to find the exact solutions. Okay, so exact solution of this equation when fx equals to 0. Okay, so we will start. We let fx equals to 0 and also substitute k equals to 3. And my equation will look something like this. I'm having negative 3. Okay, so basically if you look at this one, it is actually a quadratic form equation in terms of cos square. So you can factorize it, you can solve it by using the quadratic method, where you can try to factorize it. So to factorize this, basically I'm having 4 cos square x multiply with cos square x, and I want to get the positive x squared, right? So I will have 3 and 1 here, then plus 4 minus 3. Okay, try to solve this one. I will get 2 value for cos square, where cos square equals to 3 over 4. Another value will be cos square equals to negative 1. If we continue to solve this part of the equation, basically we won't get any solution, because if I take square root, I will have square root negative 1, where it is undefined, right? So we will ignore this part to get the value for the x. I won't get any answer for x from this equation. So proceed back to the first one. If I having cos square x, to find out the x, I need to take square root, right? So to take the square root, I'm having plus minus square root 3 over square root 4, which is a 2. Okay, so to get the value for x, you need to find out the basic angle for cos inverse square root 3 over 2 first. And you should get a 30 degree, which is actually pi over 6. Alright, so maybe you can try to find out the basic angle first. The theta, basic angle will be actually the theta. And how to get the theta is you take cos inverse and then square root 3 over 2. So please note, for the basic angle, we will always ignore the negative sign. And we always only consider the positive value, cos inverse positive value, so that it is in the first quadrant. Okay, when I get the cos inverse square root 3 over 2, I'm having pi over 6. And now, I need to go through for all the quadrants so that I can see which quadrant, the angle from which quadrant, and I want to make it as my final answer. For first quadrant, everything is positive, right? Everything is positive, and then the answer is the basic angle. For the second quadrant, sign is positive, and then to get the answer, we are taking 180 minus basic angle, or pi minus basic angle. For the third quadrant, we are having tangent positive and pi plus basic angle. Lastly, for cos, I'm having 2 pi minus basic angle. So for the fourth quadrant, means that cos is positive. Alright, so this is basically what we refer. Okay, to get the answer for x, we need to go through the quadrant first because they are mentioning that x should be from 0 until 2 pi. And now we are looking at the quadrant. Before you look at the quadrant, you look for the value. Cos, I want to consider both positive and negative. That means no matter cos is positive or cos is negative in that particular quadrant, I actually want to get the answer from that quadrant itself. Alright, so for the first quadrant, everything is positive, right? So I want to answer from this part where it should be the theta. So our basic angle theta is pi over 6. Therefore, pi over 6 is the answer. Proceed to the second quadrant. Cos is negative. I also want the answer from this quadrant. I take pi minus pi over 6 and I get 5 pi over 6. For the third quadrant here, I'm taking pi plus theta, pi plus basic angle, which is pi plus pi over 6. I'm having 7 pi over 6. And lastly, for the fourth quadrant, I also want to consider the answer from this quadrant. So I'm taking 2 pi minus theta, where we are getting 11 pi over 6. Okay, so after I go through one cycle, one round, then I'll stop because they are saying that the x is between 0 until 2 pi, which is 360 degrees. And these are all the answers that I get for the value for x. Okay, then now, part B. For part B, they ask us to use the quadratic formula. So I think this is an important keyword for us to show that when k greater than 5, the equation fx equals to 0 has no solutions. Okay, so for this particular question here, if I recall what is my function fx, so my function fx basically is 4 cos power 4x plus cos square x, then minus k. Okay, this is the original value, original function, and then they said fx equals to 0. That means I let fx equals to 0. Okay, so like what I mentioned earlier in part A, right? Basically, this equation is a quadratic form equation. To solve for the quadratic form equation, besides you factorize it, right, you can also apply the quadratic formula. Okay, so now I want to apply the quadratic formula. When I apply the quadratic formula, the value that I get is for the value of cos square x. Okay, so what is the formula? I'm having negative b, where 4 is the a, 1 is the b, and also the c will be the negative k. Alright, so what's the value for negative b? I'll have negative 1 plus minus square root b square minus 4ac. So 1 square minus 4ac, c is negative k. And then divided by 2a, so 2 times 4. And my equation for cos square x will look something like this. I'm having 1 plus 16k divided by 8. Which means basically, right, I'm having two values for cos square. One formula for cos square will be negative 1 minus square root 1 plus 16k divided by 8. Another one will be negative 1 plus square root 1 plus 16k divided by 8. Alright, so basically this is the formula for me to solve for the value of cos square x, right? Okay, then now, when they are saying that, talking about no solution, okay, maybe before we go into that part, you can have a look and analyze the solution here first, the formula here. Okay, so basically, for this part, for this particular formula, right, you can see that negative 1 minus square root 1 plus 16k divided by 8 is actually always negative. You can rephrase it like this. You can take out you can factorize out the negative, and then you try to observe this equation, this expression. For anything with the square root, it will be always positive. So positive plus 1 is a positive divided by 8, which is positive also. So the whole fraction here is positive with a negative in front. That means this whole expression is always negative. That means no matter what's the value of k that you substitute inside this equation, right? Basically, you won't get any solution for cos square, because if cos square is equals to this one, that means cos square is always negative. And when you want to take the square over become square root negative value, you won't get any solution. Okay? Alright, so you can make it like this. Negative 1 plus square root 1 plus 16k divided by x is always negative. It also means that cos square x is always negative and there's no solution for this part, no matter what is the value of k that you substitute. Okay, so we are not going to consider this one because no matter what value of k you put in, it is always negative and always no solution. And now we want to proceed to another formula for cos square x. So this is another formula for cos square x, right? Okay, so let's have a look for this one. Okay, for any function with trivial, if we want to solve it, we have to ensure that the cos square x is always between 0 until 1 so that I can have solution. Okay, right, because cos x is between negative 1 until 1, and then cos square x, basically we're having positive value, so it should be greater than 0 until 1, which also means that the function has no solution if the cos square x is greater than 1, right? Because if you have any value greater than 1, when you take the square root 1, more than 1, you get 1 point something at least. So when you want to take cos inverse for 1 point something, you will get mass error also. So that means for cos square x greater than 1, you won't have any solution. What is cos square x greater than 1? So just now we already ignore this negative formula, right? So now we try to consider this positive formula here. Cos square means negative 1 plus square root 1 plus 16k divided by 8, and I get greater than 1. Okay, I try to move all the number to one side. I'm having 8 here, and then square root 1 plus 16k greater than 9. Take square root for both, take square for both sides, I'm having 81. And if I try to simplify further, I will have 80 divided by 16, which is a 5. That means for this particular formula, right, for cos square x, we will not have any solution if I put the k greater than 5. Because if I put k greater than 5, eventually the value that I get will be more than 1, and to take square root for any value more than 1, right, I will have cos x greater than 1 point something. And if you continue to take cos inverse, you won't get any value. Alright, so this is basically how we analyze and also get the value, get the range for k greater than 5. So that means k greater than 5, we will have no solution for cos square x. Okay, so here we ended the discussion from this paper. Thank you very much for watching.